Hey everyone, in this video we are going to see the K8's overview or Kubernetes overview. So if you are new to this channel, I'm Kavil Kobarkar. I make content around open source, DevOps and DevRel ecosystem. So let's get started. So the Kubernetes is an open source container orchestration system for deployment, scaling, and management. K8s is ideal for microservice architecture. So these are the 2 points. Please note them down. And I highly recommend you writing down your notes on the pen and paper, which gives you like a sense of like it is good practice while learning, and then maybe put that on digital that as I did. So in depth, if you go ahead and understand and learn about Kubernetes, I will link down a Kubernetes detailed video down, so you can go ahead, check the video out after this video, so you will understand what I mean by the scale, deployment, scaling and management. So Kubernetes is an open source container orchestration system for deployment, scaling and management, and it is ideal for microservice architecture. Great. And then yeah, so this is like one line definitions to get a quick recap of Kubernetes. So let's look at this architecture and I will get you through all of them. So first of all, what is a cluster? So cluster is like a bigger oval, you can say. So if you say this as cluster, so whatever like whenever you create, this is like the biggest and outermost collection of all the components inside the cluster. So whatever like the nodes, the pods, etc., everything will fall under a cluster. So this is like you can say the highest outermost overview. There is like different, there is cloud provider, but we won't go there right now. But let's see all the components inside the cluster. It's a collection of all the components inside the cluster, and you generally contact like communicate with a cluster to like get information about the things inside the cluster, like how many pods are there, how many nodes are there, something like that. So this is the cluster. So cluster is a logical grouping of all the components within a cluster. So all the things here, see all the things here, remove the developer, like take the developer outside, but all the other things in here like this are inside a cluster. So these are all inside a cluster. Then there comes is namespace. So say suppose we have two we have two websites running, right? So we have front end of one website, front end of no, not front end, let's see like that. We have back end of first website, we have database of first website, then we have front end of first website, front end of second website, sorry, back end of second website, and database of second website. Now you can see it kind of feels messy even if I drew it in symmetry by chance, but yeah, it feels kind of messy, right? So if you have 100 websites in one cluster, then this would become totally horrifying, right? So what do we do is there is namespace, so it helps you categorize your resources or components for same like purpose, you can say. So if I create a namespace for website 1, and if I do like say suppose it is like a logical grouping. So if I do like like this, it is website 1. So what I will do is I will just remove and all the website 1 things will be here, and this won't interfere outside. So it's kind of isolates the resources from the crowd outside. And then if we create a new namespace for namespace called website 2, then the website 2 resources will be here. How the name say how is namespace able to select these resources and stuff, we will learn in like like moving ahead. It's like selectors and labels that are there, but this is like a namespace one that's name is like website 1, website 1 namespace, and then this is a website 2 namespace. So now if you want to see and check out and work with website two only, then we will just specify the namespace, and then we won't affect any other application running around on 100 namespace maybe, but we will be focused on one only. So this is how you group the pods and resources in your cluster using namespaces. So named logical grouping for Kubernetes components within the cluster, as I explained it. Right, what are the nodes? So virtual machines are underlying servers. There are two types of nodes. So as you can see, these are the nodes. So see, there are two types of nodes: master node and worker node. So these are two, but I think with the current latest update, it's not called as a master node or a server or slave node, something like that. It's called control plane. Just check that out once. So there are two types of node. We will mark it as same because of the image and to remove the confusion. So master node and worker node. So master node is like as you can say, master. So it manages like the two other nodes. So there might be 100 worker nodes. So one node that manages 100 worker nodes is a master node, and it has components like API server. We will see one line definitions of this to give you a quick revision. What is like API server? Key value stores like a etcd. So API server, etcd, control manager and scheduler are inside master node, and the kubelet, container runtime, kube proxies are under worker node. So this is really important, and so you should definitely remember what comes under what. So control plane that manages the worker nodes consists of API server, scheduler, controller manager, etcd, kubelet and core DNS. So this is really important. So please do remember what comes under control plane. And the second one is worker node. So kubelet, kube proxy, container runtime and pods and containers come under worker node. So if someone says if you want to work with a pod, what node will you be working with? So it might be worker node. So something like that. Try to come up with your own questions to better understand. So workloads run here. So all the running stuff is done under the worker node, and control plane like manages the worker nodes. So what is pod? The smallest unit in K8s. It's the abstraction over the containers. So as I said, the containers are there. Pod is like an abstraction over the containers. It's like OOP. The containers are like a wrapper around the pod is like a wrapper around the containers. So then the service, so used to allocate static IP address and DNS names to set of pods. So I will quickly tell you about this. So there is a pod. So as we know that pods are like a stateless like objects. Like enter Kubernetes was never designed to work with stateful data, right? So this is a pod, and when a pod is created, dynamic IP is allocated to it. So something like that is allocated to it. Okay, so there is dynamic IP added to it. And if you want to access a application, so if we are user, so at the end we want users to use our website, right? And we are using Kubernetes to host it. So at the end, for simplicity, we have to access the pod's IP address to get the application. So now we are able to run the application here. But by the definition, when the pod fails, new pod will be created. A new pod will be created immediately as soon as this pod fails. So this gets a new IP address, dynamic IP. Because it is dynamic IP, it will get a new IP address. But how will the user know if the pod has been died or something like that? It does not, the user does not care the IP address changed or something like that. But the IP keeps on changing. Say suppose 100 pods fail in a second or in a minute. Do we have to remember every little IP address for there? No. So what we do is we create a service. So we create a service and we ask our user, or we will consider it as a user for now, right? So we will ask a user to always point out at service, and this is a service, and the service will point to a pod. right? Service will point out to a pod. So the service will have a static IP, so IP is fixed for the service. But whenever the dynamic IP like changes, so say suppose this service points to pod front end, named front end, so whenever the pod recreates, the definition will be same, so all the contents and stuff will be same, so the name will be same as well. So whenever the pod gets the name front end, something like that, the service will point to it. So however new pods get created with new IP addresses, it does not matter, the service is used to help us make the IP address static. So it will always, if this fails, then new pod is created, it will point to the new pod. Then this fails, then this will point to the new pod, something like that. So service helps us make like a static IP address for the like DNS names for the set of pods, something like that. Now you understand why it is called as static IP address, right? So now Ingress, it is really easy. So translates HTTPS rules to point to service. So Ingress, so now as we see, so translate HTTPS rules to point to service. So now you can see the user, so there would be now in picture, now there would be a ingress. So now whatever request comes from user is translated so that it can be pointed towards the service, and ingress is like incoming traffic. So, and we will learn this in depth. So the traffic comes, if the traffic comes into a service pod, something like that, then it is called ingress, like it is flowing through this. And if the if the like such resources are coming, but if the traffic is flowing outside, then it is called as egress. So if it is flowing outside like this, then it is called egress. We will learn about them in detail. So it is like this, something like that. Cool. So this was ingress. So HTTPS rules of service point. API server helps user interact with KATEs using kubectl. So the user here uses kubectl to interact with this, right? So it has a kubectl, but what does kubectl talk to? So there is a API server, right? So if you do get pods, kubectl get pods, it will go to the API server. Then API server will check, okay, the kubectl is asking for pods. Then it will go through the all its definitions and check out the pods, and then return. So API server is the front. So whatever you are doing will be connected through API server. So whatever users are trying to do inside the clusters will be done through the API server. So that is the importance of the API server. So now that we know about the API server, so just remember API server is like a contact point for the cluster, so or point for the node. So whatever you want to do with the cluster will happen through API server, and the components inside the cluster as well talk to each other through API server. So we will see that like while going ahead, but this is a quick note on API server. So after that, the kubelet helps us interact with the nodes via API server, present on all nodes. So if we go ahead quickly, so you can see kubelet is here. So if you just go ahead, check, see control plane also has kubelet, and it also has kubelet. So kubelet helps us to like communicate with nodes if nodes want to communicate with each other, kind of thing, then kubelet is done. So see, kubelet connects with API server, and whatever this node wants to talk to this node, say suppose this controller, we will see what controllers are, by the way. So and if you have if you are seeing this as a revision, then you already know. So if controller wants to talk to this, then it will go to API server will contact to the kubelet, and then such goes. See, kubelet talks to the API server, and whatever happens here is done inside this. So kubelet manages and talks to inside this, but if you want to talk to this node, then you have to talk to kubelet first, and master node or control plane talks to kubelet using API server. So if etcd also wants to talk with the with this node, then it has to go to API server, then it will go through kubelet, and then kubelet will talk to this. If you want to say, suppose create a pod, kubectl create pod, etc., it will go to the API server. Okay, then scheduler will see where to put it, kind of thing. Then if it selects this node, then it will talk to kubelet and it will be created using container runtimes and stuff. Great. So that is it for kubelet. Kubectl is command line terminal for Kate. So whatever you do, there are like different dashboards and stuff as well, like Lens is there, Monocle is there, different stuff which makes like a GUI interface to communicate with your Kate's cluster. But kubectl is like a built-in command interface you get to talk to Kubernetes cluster. So you will be running a lot of kubectl commands and stuff when working with the cluster. Then cloud control manager allows you to link your cloud service provider. So it is easy. You have a cluster, you have a cloud control manager which helps you to connect to the cloud service providers. That is easy, and the name suggests itself as well. What is control manager? Watches the changes current state back to the desired state. So this is an interesting one. We will check this out. So say suppose you want 3 pods to be running at all times. So 1, 2, 3, right? So you want 3 pods to be running all the time. Now what happens is, so this is called as desired state. So not technically this would but desired state. So desired state is 3. So you want 3 pods to be running at all times, and the like this here would tell as current status, current state. Sorry for the handwriting. Current state, let's say it is current state, right? So now how will you make sure that it runs every time? Say suppose an error occurs and this pod goes down. Now you only have 2 pods, and but you want 3 at a time. So what you do is you have a control manager. You have a control manager, control manager, and it will keep an eye on these things, and it will check desired state with the current state. So if the pod goes down, now the current state is 2, which is not equal to 3. So now what it will do is it will redeploy one another pod. So say suppose the pod name for the pod first were P1, P2, P3, right? And then the current state was 3, and now 3 is equal to 3, right? So this is okay, this is perfectly good. But if the pod goes down, P1 pod goes down, then this becomes again 2 is not equal to 3. The control manager catches this, and what it does is it deploys one more pod. Now the pod name will be changed to P4, right? So see, you can actually figure out if you can delete a pod deliberately and check out if new pod with new name comes up. So this will happen. So that's what control manager do is it it checks desired state, it checks current state, and if this does not match, then it makes sure that desired state is always available on your cluster. So that's kind of it tries to check that out. Scheduler determine where to place the pods on the node. So say suppose there is a node which has 5 containers running and 5 pods running, and this has 3 like pods running. So this is node 1 and this is node 2, and you want to create a new pod. You say create new pod, then where should it put? So there are worker like 2 nodes there, 2 worker nodes there. There might be 100 or 1000 worker nodes if it's a really big cluster, right? So where should it put it? So it goes through scheduler, and the pod goes here, says, hey, can you give me a good place where I can reside. It will check on different stuff, how many like memory is remaining, CPU is remaining, how much is utilized and stuff, and it will prioritize and give rankings and stuff to the nodes, and it will decide, okay, go and sit on node 2, and then the new pod comes here. So this is a pod, I will just give it like this. So the new pod comes and sits here. So whenever a new pod comes, where it should be sitting is determined by the scheduler. So that's like a quick definition of scheduler, which is important. And now kubeproxy provides routing and filtering rules for traffic support. So if you go here, see kubeproxy, now filtering, like network filtering and all the like rules and stuff for the networking is handled by kubeproxy, like filtering rules for traffic support. So what traffic can come, what traffic can't come to the pod, something like that will be handled by kubeproxy. So proxy means it is related to networking, so it is really easy to understand. So kubeproxy technically handles the networking stuff that is happening around inside your cluster. Go ahead and just you can create filters and stuff, so it will ensure that the filtering process is available on your pods, something like that. What is network policy? It's like a virtual firewall between your namespaces, pods, nodes. So it's not like your like technically your all pods can access all pods, right? But if you don't want that, you don't want your front end pod directly access your database, you want only your API or your backend server to access your database, right? So you create a network policy so that your front end pod cannot contact with your database pod, but only and only it will be contacted by the backend pod only. So you can create a rule where you will say only allow backend pod to communicate. Yeah, so you can define that what pods can communicate. Then the second is, then the next is config map. So config map is used to store non-confidential data into the key value pair. So it is similar, like it is like a key value pair set. You can imagine it's like a key value pair file where you store non confidential data. So that's what that is a one line definition of config map. If the data is non-confidential, you can share it in a config map, and then multiple application can access, multiple pods can access the config map to use the data. And then secret is like used to save more sensitive data like passwords, token, keys and stuff. So secrets are used that. So definitely a difference between config map and secrets is that config maps have non-confidential data and secrets have confidential data, and both of them are key value pairs as always. That is the common thing. Then volumes is like mounting storage to store the data of application to use and preserve. So as I said, pods are stateless, right? But what if you have database pod and you don't want after the date like it is deleted, your database is gone, right? You want your database to be there. So what you can do is mount a storage. So volumes are like it is able to mount the physical storage on your system, the physical storage on your system with your pods and your application. So whenever data is collected, it stores safely in your hard storage on your local system. So whenever the pod is deleted, new pod is created, it can again link it up and your data is persisted. So volumes are used to persist your data. So if you don't care about your data, you don't need volumes and stuff. But if you want to persist your data, then you need volumes, right? What are replica sets? To maintain stable set of replica pods running in given time. So you want like 3 pods running, so you create a replica set of 3 pods. So again, this helps like for like control manager, as I said. So replica sets you can give here. If you want to increase replica, you just give like a replica set scale and replica set will handle it. So say suppose you have 3 pods in replica, now you want 100. So you just go to replica set and tell the replica set I want now 100, and replica set will create 100 pods for you. And every time a replica set is created, it will create 100 pods. If you want 50, just go to replica set, tell it 50, it will delete 50 pods. So replica set maintains the stable set of pods running on given time. Great. Deployment is a blueprint of pod. So let's just see that. So it is like a kind of little bit overview. So you have say suppose you have container, which is smallest, then you have pod here, then now you want stable amount of pods, so you create like a replica set. So now if you give 10 replica set, it will create like a 10 pods in here, something like that. So like this, it will create 10 pods in here. So it is like a, this is a replica set. And now you can like wrap around, like you can create a deployment here, and which is like a wrapper around like this. And deployment is like a blueprint of pod. So whatever whatever the pod, so pod should have what image should have. So image can be nginx, something like that. What are the different things, like whatever you need in pod, you will give it here. So container names, and it acts like a blueprint. So you can understand it as like a deployment is like a blueprint of pod, you can say. Okay, so now what is entry? So plugins and components functionality that are provided by default inside the main repository. So what are like the plugins, components and functionality that are provided by default are called as entry. So say suppose there are 5 plugins that are provided to you by default by a cloud service provider or someone else, then it is called an entry. And if you install a external plugin, external service to your cluster and something like that, then that is called as outtree. This is like really basic definition of it, and pretty much like one liner definitions with I tried to give like a good overview of the stuff for your revision. Yeah, and that's it for this video. If you like the video, make sure you hit like button. That really helps support the channel. If you would like to get notified about such similar videos, then please subscribe to the channel and check out the KCNA preparation playlist. There are 2 to 3 videos should be already there, from explaining about the examination to starting the preparation. So I guess 3rd video, if I'm not wrong. But yeah, make sure you check that out, and I will see you in the next one. Bye.